not planning to, have more than one correct answer. So don't worry about it for the quiz or test purpose. This is only for this in class problem only. Yeah.
Is it
So Kevlar is commercial name for glass fibers, aramid fibers, carbon fibers, none of the above are fiber reinforced composites.
I think it's B.
Is B aramid fibers?
Yeah.
Yes, aramid fibers. They are actually commonly named as, their commercial name is Kevlar. The bulletproof jackets, all those things are made up of, they're very, very strong um, fibers known as aramid fibers. Okay, the right answer is B. All right, guys, next question for Jacob. Wood is composed of chains of cellulose molecules bonded together by a natural polymer called.
I'll go with A.
You'll go with A. So in wood, cellulose are bonded together by a natural polymer called lignin.
Yeah,
You sure?
I'm gonna stick with it.
I'll just stick with that. Okay. Um, what about what is the role of hemicellulose then?
Can't quite remember.
Okay. So um, as I said, see, in wood, the cellulose fibers, they are aligned. They are more crystalline, so they are aligned in a preferential direction. Okay, they are highly crystalline. However, they are tightly embedded in two components. The one is the hemicellulose. So hemicellulose, they are branched amorphous chains. Okay, so um, so it is definitely embedded inside, embedded tightly with the hemicellulose chains. And the lignin is a complex cross-linked 3D structures which actually act, it actually act as a paste and provides the rigidity to the wood. Okay, so in general, these cellulose molecules, they actually bonded by both of them. They are connected. They are bonded with the lignin. They are also bonded with the hemicellulose. So it will be C, both of the above. Okay, next question for Christopher Brown. Which one of the following is incorrect about composites?
I'm here. I'm just reading it. Give me a sec.
Okay, yeah, sure. So is it the continuous phase transfer the load to the dispersed phase? Dispersed phase transfer the load to continuous phase? Or composites have macro to micro constituents in different phases, or none of the above? Which one of the following is incorrect?
I think if I got this question on a test, I'd pick D.
You'll take D, none of the above. So
Yes.
all the statements are incorrect.
Yes.
Could you please read the questions as well as the options very carefully?
Okay, sure. Let me take a second look here.
Yep.
Is it A, continuous phase transfer the load to dispersed phase?
So that's an incorrect answer. because it says you have to select an incorrect statement. Okay, composites have two phases, right? One is there's a continuous phase, which is the matrix, and then we have a reinforcement or a dispersed phase. Okay, so the continuous phase, um, they try to house, they try to protect this reinforcement, these particles or these fillers, and then they transfer the load to the dispersed phase. Okay, so A is correct. Also, the composites, they have micro to micro constituent which are mixed together in a different phases. So that is also correct. So the incorrect statement here is the dispersed phase transfer the load to a continuous phase. That's a wrong statement. Dispersed phase takes the load from continuous phase, not the other way around. Okay. All right. Next question for Logan. Nanocomposites have matrix and nanofiller insoluble in each other, continuous phase less than 100 nanometer, dispersed phase less than 100 nanometer, nanofiller is harder than the matrix, or matrix is harder than the nanofiller.
I'm gonna go with B.
So continuous phase less than 100 nanometer, those are nanocomposites. So once again, I mean, you may have more than one correct answer. So okay, so let's go one correct answer by each student. Okay, so you are saying that the nanocomposites have continuous phase that is less than 100 nanometer.
Yes, sir.
Okay. See, once again, the nanocomposites also have two phases. One is a continuous phase and another one is a reinforcement phase. Okay, or like the filler or the particles. Okay. um, it can be nanoparticles, it can be nanotubes, it can be nanofibers, it can be anything. Okay, so that a dispersed phase or the reinforcement or the filler, the reason they are known as a nanocomposite is that the dispersed phase or the particles, they should be nanoparticles. Okay, and we know that the nanoparticles means what? They should be smaller than 100 nanometer in size. Okay, not the continuous phase. For example, if you add carbon fibers in polymer, okay, most of this I think this um, aerospace industries, automobile industries, I think these days they are planning to use these nanocomposites. So they are adding these carbon nanofibers into polymer. So the polymer is a continuous phase. Okay, while these nanofillers, they are the dispersed phase, which are less than 100 nanometer. Okay, so it is not B, it is actually the C. Batana, do you think is there any other answer which is correct in this out of these five? Or it is just one correct answer? Is there a chat here? Okay, maybe A. Okay, so maybe A. Vatana replied that it could be A. So A means the matrix and nanofiller are insoluble in each other. Yes, because that is what the composites are. Composites, your matrix and the filler, they are insoluble in each other. So A is also correct statement. Okay. Is there any other Stefan Boudreau? What do you think? Is there any other correct answer here other than A and C?
I thought D was the answer.
D would be also correct. Nanofiller is harder than the matrix, or the matrix is harder than the nanofiller.
D.
D, nanofiller is harder than the matrix. Yes, very good. So in composites, the nanofillers or any particles like these fillers or the reinforcement phase, the dispersed phase, they are actually harder than the matrix. So correct answer here are A, C, and D. Okay. And any doubts with this question, guys? Before we move to the next problem. Next problem for Justin Chauvin. Next problem for you. Read the following statement carefully. Nanocomposites are stronger than their parent matrix material. The reason behind this statement is, the nanofillers are lightweight, nanofillers have high volume to surface ratio, nanofiller restricts slips, nanofiller facilitates plastic deformation, or all of the above. Which statement, read the statement carefully, which statement best describes why nanocomposites are stronger than their parent matrix material? Justin.
I'm here. I'm still reading. I'm reading and writing.
Yeah. No problem. Take your time.
It's all of the above.
It's all of the above.
Yes.
So, okay, I have to pass this question to some other, another student. Jordan. Jordan, can you hear us?
Is it C?
It is C, nanofiller restrict slips. Are you sure, Jordan?
Yes.
Yes, right answer is C. The nanofiller restrict slips. C. The reason is, okay, Jordan, why don't you explain this? Why did you choose C?
Is it because they like fill in to where it can't slip and then it has like more boundaries?
Okay. Well, anyway, so the correct answer is C, nanofiller restrict slips. And we learned in one of the previous chapters that if there is anything that can restrict the dislocation motion, that can restrict the slip, that will make the material stronger, right? So how does the nanofillers restrict the slip? How does the nanofillers uh, they stops or they restrict the plastic deformation? See, the nanofillers, as the name indicates, they are very small. They're less than 100 nanometer. Okay, so they're not as small as atoms, but they are uh, kind of quite similar to these small atoms. So they restrict the slips at an atomic level, right? So they can once they are embedded inside this matrix throughout, then it will restrict the movement of these slips, and then it will improve the mechanical properties. So right answer here is C. Okay. Next question for Andrew. Which one of the following is a disadvantage of composites? You have to figure out the disadvantage.
I'm gonna go with D, controlled anisotropy.
Controlled anisotropy, and that is a disadvantage.
Mm-hmm.
Okay. Why do you think it's a first of all, what is anisotropy? What is controlled anisotropy, and why do you think it's a disadvantage of composite?
Let me look through my notes real quick.
Okay. In the meanwhile, I would like Mason. Mason, there are two Mason here. Mason um, Rigsby and Mason Dufresne to read the options carefully and then try to figure out which one, because there might be more than one answers here, which are the disadvantages of composites.
Would one be low ductility?
It's what once again, Mason, what did you say?
Low ductility.
Low ductility, yes. So one of the answer is a low ductility. The nanocomposites, because and why do you think, Mason? Why they have a low ductility?
Um, isn't it because they're like fibrous, so they aren't
Yes, yes, very good.
like
Because the
moldable?
fibers are brittle. So the fibers are brittle. That's why they have low ductility. Okay, so that is one of the disadvantage of composites. Is there any other disadvantage?
Yeah,
Mason,
B.
Mason Rixby. So
Uh,
Mason
B.
B, low impact resistance. Why? Why they have low impact resistance?
Um, I'm not sure exactly.
See, once again, it's because the fibers are
Oh,
brittle. If you compare between polymer and glass, which one has a low impact resistance?
uh, I'm not sure.
Mason Rixby. Okay, so if you take a hammer, or if you take a piece of a plastic bottle, or if you have a glass bottle, and then you drop them on the floor, which one is most likely to break?
Wouldn't it be composites?
No, no. My question was, if you have a glass bottle and if you have a plastic
Oh,
bottle,
I'm sorry.
okay, and then if you drop them on the floor, which one is most likely to break?
The glass bottle.
Glass bottle, obviously, because it has a low impact resistance, and glasses are brittle, right?
Mhm.
Okay. Similarly, in the composites, the fillers or the fibers, they are brittle. Okay, so because they are brittle, so they have the composites have low ductility, they have low impact resistance. Okay. Now, lightweight is not a disadvantage, because lightweight is even better because you can use it for many applications. Now, controlled anisotropy is also an advantage of composite materials, because we can control the properties, we can control the mechanical properties by aligning the fibers in a preferred direction. So, controlled anisotropy is actually an advantage of a composite material. Okay, so the correct answers here are A, low ductility, and B, low impact resistance. Okay, next question. Oh, I don't know if I asked to. Okay, Abigail, Kevlar fibers have the following properties: high longitudinal tensile strength and lower compressive strength, low longitudinal tensile strength and higher compressive strength, hydrogen bonding between polymer chains, and or all of the above. Kevlar fibers.
Is it A?
It is A. They have high longitudinal tensile strength and lower compressive strength. Okay, so one of the answer is A, or it's just A. Logan, Logan Pitre, what do you think? Is there any other correct answer here? So Abigail said one. A is A is have the following. The scabulars have the properties, and the following properties. What they have: high longitudinal tensile strength and lower compressive strength. Logan, do you think is that's just A, or is there any other correct answer here?
If there were to be another correct answer, I think it'd be C.
C, yes, C is also correct answer, because they have hydrogen bonding between polymer chains. Kevlar fibers, they're actually known as they are made up of aromatic polyamide fibers. That's why they are known as aramid fibers. Okay, aromatic polyamide fibers. So they have hydrogen bonding in between the longitudinally aligned polymer chains. So correct answers here are um, is there chat here? No, there is no chat. Okay, so the correct answer are A and C. Okay, next question for Garrett. Which
Okay.
one of the following is not an attribute of the stress strain behavior of composites when stress is applied in longitudinal direction? you have to figure out which of the following is not an attribute of a composite material when stress is applied in a longitudinal direction. So strain in matrix is higher than strain in fiber. Matrix and fiber deform elastically and linearly during elastic deformation. Stress in fibers is higher than stress in matrix. Composite failure starts at fracture strain of fibers, or none of the above. Which one of the following is not an attribute of composite material? Garrett.
Is it none of the above?
None of the above. Yes, very good. The right answer. All of these statements, they are the attributes of composite materials when the stress is applied in longitudinal direction. Right answer is E. None of the above. Okay. Then next question, next problem for Ryan Callahan. Okay, say reasoning and assertion problem. The strength of polymer chains can be improved by introduction of an aromatic side group. Okay, reasoning behind this statement is that in Kevlar fibers, the aromatic rings causes steric hindrance to rotation within the polymer chain.
I'm gonna say 1.
One means both the statements are correct, but the reason does not explain the assertion.
Yes.
Okay, so let's go one by one. Okay, or is there any other person who would like to have a different opinion? Matthew McRae. What do you think, Matthew?
I'm thinking.
Yep. So assertion statement is that the strength of a polymer chain can be improved by introduction of an aromatic side group. Okay. Now you are actually applying your knowledge from your previous chapter. Okay, you need to apply some knowledge from you acquired in polymers, and you are using that knowledge in this chapter. So can we improve the strength by introduction of a aromatic side group? Did we talk about the ways to improve the mechanical strength of polymers? Was one of the way to was the introduction of an aromatic side group or a bulky side group?
Yes, sir.
Okay, so the assertion is a correct statement. Now, reasoning is in Kevlar fibers, the aromatic rings causes steric hindrance to rotation within the polymer chain. Do we have aromatic rings in Kevlar fibers?
I didn't think so.
Well, see, Kevlar fibers, they are also known as aramid fibers, right? What does I explained in the class also? Aramid. Why does the aramid means? Aramid means AR means aromatic, and AMID means amide group. Okay, so they have aromatic side groups, and they also have the amide groups. So that's why they are known as aramid fibers. The Kevlar fibers are also known as aramid fibers because they have the aromatic side groups. Okay, so both the statements are correct, but does the reason explains the assertion or not? Yes, it is explaining the assertion very well because Kevlar fibers have the aromatic rings that can cause the steric hindrance to rotation within the polymer chain. That is why the strength of the polymer can be improved. Okay. So when the assertion and the reasoning, the both are correct statement and the reason explains the assertion, you choose number 2. Okay. We go to next question for Graham Kasi. Next problem. Oh, it's a true and false. Very simple one. Graham, is for you. Wooden block possesses excellent strength in the direction perpendicular to the cellulose fibers. Is it true or false? Yes, it is. It is actually in parallel direction. In perpendicular direction, it is actually weak. Okay, so it's a false statement. Okay, I think we may have one more question, I guess. Um, let's see. I think all are okay. I think this is the last problem, guys. And last problem is a math problem. Okay. So in that math problem, what you have is a piece of wood containing moisture, weighs 165.3 gram. Okay, and after oven drying to a constant weight, weighs around 147.5 gram. What is its moisture content? So I would like you guys to calculate it and then let me know. I'll give you a couple of minutes to calculate. So moisture content is actually the weight of the water. So you need to first calculate the weight of the water, okay, in the wood, divided by the weight of the dry wood, okay, and then times 100. So that will give you percentage. So that will give you the moisture content in percentage. Okay. So how will you determine the weight of wood here? Oh, weight of water here, not the weight of wood. Weight of wood. We have the weight of a dry wood. We have the weight of wet wood. Okay. So if you subtract both of them, you will get weight of water. Okay. So subtract 165.3 minus 147.5. I think that will give you that gives what? 12, right? So 12 divided by 147.5, no, that will give you 17.8. Okay, 17.8 divided by 147.5, that will give you around 0.12. If you multiply by 100, that will give you around 12.06 percentage. Okay, so maybe I can write it here. You guys
When
can
doing
still
that
see?
kind of problem on the test, do you want to surround the two places?
Yeah, I think that should be fine actually. Okay. So you want me to type it or you guys got it actually? I think I will write the final answer. Is that what you got? All of you?
Yes, that's what I got.
Okay. You guys can still see the answer, right? I'm sharing the screen. You can see it, right?
Yes, sir.
Okay, that's the correct answer. Okay. Once again, what you need to do is you need to in order to determine the weight of the water, you need to subtract your wet wood by your weight of the dry wood. That will give you the moisture content. That will give you the amount of the water in the wood. Okay. Take that amount of the water divided by the weight of the dry wood and times 100. That will give you the percentage moisture content. All right, guys. So with this, we are done with this problems. If you want me to go back to any question,